Welcome back to Mr. McLean's Physics 30 class. Today we're going to be looking at question number 3 from the Mechanical Energy booklet. I should warn you, you may hear some background noise in this one. My dog has her bone. So we'll try to work through it. Hopefully it won't be too distracting. So in this question, we're dealing with a 2-kilogram rock which starts from rest at a height of 20 meters. And ignoring air resistance, they want us to determine the kinetic energy, gravitational potential energy, and total mechanical energy at each of the following heights, 20 meters, 10 meters, and 0 meters. So let's start with a diagram to help us conceptualize what's going on here. So I'm going to draw it like this. This is my little diagram. So here is my 2-kilogram rock. Mass is 2.00 kilograms, and height at this point is 20.0 meters. This here is our ground state, which is 0 meters. And somewhere in the middle is going to be the 10-meter point that we'll deal with. Now they want us to know what is the mechanical energy, potential energy, and kinetic energy in each of the states. So let's start with the first one. So in the first one, this is when we're dealing with it at 20.0 meters. So at this stage, we know that mechanical energy is going to be equal to the potential energy plus the kinetic energy. And they told us that the velocity of the rock to start with was at rest, which means 0. So the velocity for the kinetic energy term is going to be 0. 0 times anything is 0. So this whole thing will just go to 0. And we can see now that mechanical energy will be equal to the potential energy. So let's calculate and find out what would the potential energy in this case be. So using the potential energy formula, potential energy equals mass times gravity times height, we can find that it's going to be 2.00 kilograms times 9.8 meters per second squared times 20.0 meters, and we're going to wind up with 392, yes, kilogram meter squared per second squared, which hopefully you can recognize as 392 joules. So the potential energy is 392 joules, the kinetic energy is 392 joules, and as we determined, kinetic energy is 0. So this actually turns out to be a lot simpler than you might initially think the question would be to start.